You ever just stand in your laundry room staring at a machine that cost you $1,200 and it's humming along like everything's perfect? It spins, it drains, it sings that little electronic jingle. But deep inside that white metal box, something is already having a very quiet conversation with the grave. It's not making a sound your ears can catch. It's whispering in numbers: a stray 0.3 amps of leakage current, a 2 kHz spike on the ground wire, a single drop of water sitting exactly 1 centimeter deep where it shouldn't be. Right now, as you're listening to my voice, there are at least 7 things eating your washing machine from the inside out. And I'd bet my favorite fluke meter that the last technician who charged you a couple $100 to stare at it didn't find a single one of them. My name is Silas, and I've spent 40 years elbow deep in the guts of appliances, playing coroner to machines that were murdered by cheap plastic and planned obsolescence. Unplug the machine first, you'll hear me say that a lot, and let me show you what your washer is trying so damn hard to hide. First, grab your clamp meter. No, I mean it. Pause this, walk out to the garage, and get the meter. Because the very first sign of impending doom isn't that grinding roar you hear on YouTube disaster compilations. It's a ghost. Inside the motor, there's a bearing sealed in a plastic housing, and between the steel balls and the outer race, there's a thin film of grease. The factory designed that grease to die after a certain number of wash cycles. It's a micro timer. As the grease breaks down, it creates an unintended electrical path to the motor frame. Now you've got a tiny, almost innocent leak of AC current riding the ground wire somewhere around 1/4 milliamp. Most people will never look. They wait for the noise, the mechanical death rattle that says the balls have turned into little squares. But that 1/4 milliamp, that's the bearing sending you an email from the afterlife before it's even dead. Set your true RMS clamp meter to AC milliamps, open the jaws, and clamp it around the green or bare copper wire coming off the motor. If the display sits there quiet, reading dead zero or close to it, the bearing's electrical insulation is still holding. If you see it flickering past 0.25 milliamps, you just caught a ghost. That bearing's grease has turned to varnish, and it's only a matter of time before the mechanical screaming starts. And by then you're replacing the whole motor instead of just a $15 bearing. In nearly 4 decades, I've watched people scrap perfectly good machines because they didn't listen to the silence. The physics is basic. Current follows the path of least resistance, and when the grease fails, that path is suddenly through the outer race to ground. You're literally eavesdropping on the soul of the bearing, negotiating with entropy. So before you do anything else, unplug the machine, pop the back panel, and go hunting for that ghost. A bearing replacement takes an hour and costs less than a pizza delivery. A seized motor costs you $200 or $300 and a trip to the scrap yard. The machine isn't lying, it's giving you a sign in a language you just learned to read. Now let's step out of the laundry room and into the kitchen. You open your Samsung fridge, and the display flashes that dreaded DE error. Your heart sinks. You already hear the sound of a cash register. A rookie tech walks in, sees that code, and immediately changes the door lock assembly. $35 gone. The error comes back the next morning. So he orders a new main control board. $400 plus labor. You're out $435, and the real culprit is a little aluminum can the size of a button mushroom that costs 30 cents. That capacitor, usually labeled cone 101 on the board, sits right in the lock circuit's DC power supply. It's supposed to filter the voltage smooth as butter. After years of heat cycling, it dries out. The capacitance drops, the voltage sags below 11 volts DC, and the lock can't send the correct position signal back to the brain. The board thinks the door is still wide open and throws that DE code like a dramatic soap opera character clutching her pearls. The tragedy is entirely on that little capacitor, exhausted from trying to hold the line. Grab your multimeter, unplug the fridge first, obviously, and find the lock connector. Stick your probes on the power wires while a helper plugs it back in. If you see anything less than 11 volts DC, the capacitor is done. Replace it. I keep a handful of those caps in my van because I've seen this exact failure more times than I can count. The lock is fine, the board is fine. The machine just needs that 30-cent part replaced. Here's the philosophy: appliances rarely die from a single hammer blow. They die from 1,000 tiny paper cuts, and the smallest wound, the one nobody bothers to look for, usually takes down the whole system. That capacitor didn't explode, it just got tired, like a heart that stops because it's been beating too long in a hot room. So next time your Samsung cries DE, don't reach for your credit card. Reach for your soldering iron. And listen to that low, tired buzz the board makes when the voltage is sagging. That's the sound of a 30-cent component whispering goodbye. You can either answer that whisper or pay $400 to ignore it. Back to the washer. You think your machine is running quiet. That silence is a lie. I read a study out of the University of Pretoria a few years back. 80% of bearing failures give zero audible warning until the final 30 seconds before catastrophic seizure. The machine sings you a lullaby while it's grinding its own guts into metal paste. But there's a way to hear that lie before your ears do. Your smartphone has an accelerometer that's more sensitive than a technician's expensive vibration probe. Download a free app like Spectrum View, tape the phone firmly to the side of the drum, and run a spin cycle at 600 RPM, standard wash speed. If you see a sharp peak at 20 to 30 Hz on the frequency plot, especially with little harmonic spikes at the second and third multiples, that bearing race is already pitted. It is no longer round. The balls aren't rolling anymore. They're sliding, chattering, carving a groove into the steel. 20 Hz, by the way, is the fundamental frequency of a very slow, very ominous heartbeat. You won't hear it, but your phone will paint it on the screen like an EKG of doom. The bearing is still rotating, still pretending to work, while your clothes come out perfectly clean and you think everything is fine. That is the dark poetry of entropy. The machine has about 800 more loads before it sprays metal shavings into the drain pump and the whole thing locks up. So here's what I want you to do. Unplug the machine, wait for the drum to stop, and put your hand on the inner tub. Spin it by hand. Do you feel a very faint rumble, like a cat purring before it sinks its teeth into your hand? That's the pitting. That's the death rattle still in its infancy. You can confirm it with that spectrum analyzer. Once you see those peaks, you've got a window of opportunity. Replace the bearings now and save yourself a $500 basket case later. Most people wait for the sound. By then, the metal has already spalled off and you're shopping for a new machine. Don't be most people. Now there's another gatekeeper in your washer, and it's a simple rubber lip seal. The seal keeps water out of the bearings. When it starts to wear, the pressure between the lip and the shaft drops and capillary action pulls moisture inward. You can diagnose this with a trick that Miele trains their techs to use, and it costs almost nothing. Grab a drop of blue ink, the kind you use to refill a printer cartridge works perfectly. Unplug the machine, open the back panel, and find the shaft seal where it meets the drum spider. Dab that single drop of blue ink right on the seal edge. Plug the machine back in, let it idle through a short cycle for about 5 minutes, no laundry. Then unplug it again and look. If the blue dot has migrated inward past the seal, you have just watched the death certificate of that seal print itself in real time. That is raw capillary action at work, basic physics. No pressure gauge, no thermal camera, just fluid obeying the laws of surface tension through a gap you can't even see. The seal was engineered to eventually fail because planned obsolescence loves a quiet assassin. If that ink disappears inward, water has been doing the same thing, only slower and without the bright color. Your bearing is now living on borrowed time. The next sound will be a low growl that sounds like the machine is grinding its own teeth. And once you hear that growl, it is already too late. The drum bearing is done, and replacing it isn't a simple repair. It's a major surgical operation that requires pulling the entire tub assembly. So a drop of ink tells you the future. Reality is a blue dot. If you ignore it, the machine will have the last laugh. Speaking of laughs, let me tell you about an LG washer that likes to gaslight its owners. You see the TE error blinking on the display, and every fiber of your being says thermistor. $50 later, you swap the sensor, pat yourself on the back, and 2 months later the drum starts screaming like a feral cat in a trash compactor. That noise isn't a sensor problem, it's your money walking out the door. Here's the ugly truth they don't cover in appliance repair school. That TE code is a false flag. The real culprit is usually a pair of seized bearings. When the bearings lock up, the motor has to pull massive current just to overcome the friction. That extra work creates heat, enough heat to trip the overheat protection circuit. The control board sees the temperature climbing into the danger zone and assumes the thermistor is faulty. Classic misdirection. The machine is lying to your face, and your parts cannon response just made you a co-conspirator. A real diagnosis takes 3 minutes. Unplug the washer, access the motor wiring, and clamp your ammeter around one of the power leads. Plug it back in and run a spin cycle with an empty drum. If the current draw stays above 3 amps steady, your bearings are toast, locked up tighter than a bank vault. Anything below that, okay, maybe the sensor was legit. But 9 times out of 10, that false TE is hiding a mechanical death sentence. I had a customer once who ignored that noise for 3 weeks. By the time I got there, the bearing had welded itself to the shaft and the belt had ripped clean through. The repair went from a simple bearing swap to a full tub and motor replacement. On the drive back, I kept thinking the machine told him something was wrong, but it used the wrong language and the customer listened to the code instead of the scream. Next time you see TA, don't reach for the credit card. Reach for the ammeter. Or at least put your hand on the drum and feel if it spins with resistance. That grinding hum isn't a sensor, it's the washer telling you in plain mechanical terms that it's time to say goodbye or time to open the toolbox. Now let's talk about a mistake that almost cost a friend of mine $700. He had a front loader that would spin intermittently, sometimes not at all. The control board error pointed to motor communication failure. A local shop quoted him a new board and labor that came to just over $700. I walked over with a $5 neodymium magnet, a Hall sensor, and a cheap pocket oscilloscope. We glued the magnet to the motor pulley, fixed the Hall sensor a few millimeters away, and spun the drum by hand. The sensor spits out a pulse train as the magnet passes. Count the pulses, do a little math for pulley ratio, and you know exactly how fast the shaft is spinning relative to expected. If the pulse count is off by more than 3% from what the math says it should be, your shaft is crooked or your bearing is worn out of round, and that small mechanical asymmetry is throwing off the motor's feedback loop. The board wasn't dead, it was just receiving garbage data from a mechanically bent shaft. We replaced the spider and bearings for about $80, and that machine is still running 10 years later. The board was a paperweight waiting to be sold to an unsuspecting homeowner. Basic physics, again, a bent shaft changes the magnetic field timing, the sensor reports nonsense, and the board shuts down to protect itself. Nietzsche said what doesn't kill you makes you stronger, but Nietzsche never had to pull a 30-pound drum out of a washing machine at 2 in the morning because a bearing went asymmetrical. The real philosophy is simple. The universe is basically a giant washing machine, and entropy always wins. Your choice is whether you fight it with a $5 sensor and some YouTube knowledge, or let the planned obsolescence industry take your wallet for a ride. And speaking of tools that can save your ass, I keep a Klein digital caliper in my back pocket. It costs about $25 and tells you to the thousandth of an inch whether a shaft is still true. No wishful thinking, no guesswork, just a hard number that saves you from becoming the next customer who learns the hard way. That brings me to the last and most brutal failure. The 1mm death sentence in your dryer. You ever push something just a little too far, hoping the universe will cut you a break? Driving with the gas light on for 3 days, ignoring that weird clunk from the dryer because it still tumbles. Spoiler, the universe does not cut brakes. A survey of over 500 independent repair shops I dug through a few years ago found that nearly 90% of dryer failures ending in a full tub replacement start with exactly 1mm of shaft play. Not 2mm, not a wobble you can see from across the room. 1 single millimeter. Unplug the dryer, open the door, and grab the drum at the front edge. Try to lift it and push it side to side. If you feel even a hint of slop, you need to measure it. I keep a piece of 0.5mm copper blade in my kit, standard thickness for many feeler gauges. Slide it between the drum shaft and its housing. If it fits with room to spare, the metal is already gone. Not deformed, not worn, gone. Over thousands of cycles, that shaft has carved a groove into itself. The bearing might still be perfectly fine, but the shaft is dead. Once that play reaches about half the depth of that copper blade, physics says the battle is over. No epoxy, no shim stock, no YouTube hack will fix it. I once had a customer who tried to pack the cavity with metal epoxy after watching some video from a guy who claimed it worked. The whole assembly locked up so hard the belt snapped mid-cycle, and the drum seized so violently it bent the front panel. The repair escalated from a $300 tub assembly to a $600 disaster plus a mangled cabinet. When the shaft starts dropping, the game is over. No temporary fix. No cheat code. Just a trip to the parts distributor with your wallet open. The ancient Stoics believed you should meditate on your own mortality every day, not to be morbid, but to remind yourself what's worth fighting for and what's just noise. Your dryer shaft has a mortality too. The The moment it drops that first millimeter, it's signing its own death certificate. The only question is whether you're going to let it drag the rest of the machine down with it or cut your losses now. That digital caliper I mentioned will tell you exactly where you stand. Measure the shaft diameter in 3 places along the bearing race. If the variation is more than a few thousandths, order the new assembly before you're stranded with a pile of wet laundry and a smoking motor. So there you have it. 7 hidden failures lurking in the shadows of your laundry room and kitchen, all of them detectable with simple tools and high school physics. A clamp meter to catch bearing ghosts, a multimeter to spot the tired capacitor, a smartphone app that hears the silent death thrum, a single drop of ink that reveals a leaking seal, an ammeter that unmasks a lying TE code, a Hall sensor and magnet to outsmart a crooked shaft, and a caliper or copper blade that measures the end of the line. Every one of these diagnoses costs less than a coffee date, and every one of them can save you from a repair bill that looks like a mortgage payment. The manufacturers are counting on you not knowing this stuff. They design these machines with expiration dates baked into the grease, the rubber, even the software. But you now speak the language of the machines. You can read the whispers before they become screams. If this walk through the appliance morgue saved you $1 or saved your sanity, then maybe stick around. I don't do fancy production tricks or miracle cures. I just do reality, one messy repair at a time. Hit that subscribe button if you want to stop throwing money at machines that are literally begging you to diagnose them with basic physics. And if you're not yet, fix that now, because I'm going to keep opening these white metal coffins and showing you what's really going on inside. Unplug the machine first, always. I'll see you in the next one where we might just tear into your fridge. Who knows what it's hiding?